Hi guys, welcome back. We are talking about identifying variables today in this podcast. So let's begin right away. The objectives for today are students will learn to identify independent and dependent variables, students will learn to identify controls, and students will learn the importance of control and experimental variables. All right, so I'm going to talk about each of these, and at the end of the lesson you should be able to understand and explain all of these objectives. All right, so the first thing we're going to talk about are the different types of variables that exist in an experiment. In order to have a really good experiment, we have to be able to have different variables that we change, variables that we measure, and ways to compare to see if we've had success. So, the first variable that we're going to talk about is the independent variable. All right, please note that I used an I right here, and the I is going to be down here as well. Those are very important. It's a way to help us remember. The independent variable is something that is changed by the scientist. It's what is being tested. It's what is being manipulated. It's the input variable. But more importantly, a definition that can help you remember is it's what I decide to change this. It's what independent, see what I did there? Independent is what I change in an experiment. So, for example, let's say we wanted to test to see how much sunlight a tree needs to grow. So I have two trees, tree 1, tree 2. Let's say I give tree 1 5 hours of sunlight, and I give tree 2 1 hour of sunlight. Okay, what am I changing? What is my independent variable? My independent variable is the amount of light that I'm giving them. I am changing the amount of sunlight that they're receiving. Okay, that's my independent variable. Donuts. Everyone loves donuts. Let's say I have a hypothesis that chocolate donuts make you gain more weight than regular donuts. So I have Billy and Susie. I give Billy a regular donut, and I give Susie a chocolate donut. I give them 5 donuts a day for a week. At the end of the week, Billy's gained 2 pounds and Susie's gained 4 pounds. All right? What did I change in this experiment? I changed the type of donut, because our hypothesis was that chocolate donuts made you gain more weight than regular. So I changed the type of donut. Okay, so independent variables, it's what I change or you change in an experiment. All right, the next type of variable that we're going to talk about are dependent variables. Dependent variables, it's something that might be affected by the change in the independent variable. All right, it's what is observed, but more importantly, is what is measured. All right, and dependent variables are measured. They're data that's collected during the investigation. It's the output. All right, so let's go back to my tree example. Remember tree 1, tree 2. Tree 1 received 5 hours of sunlight. Tree 2 received 1 hour of sunlight. That was my independent variable. I changed the amount of sunlight. Well, what's being measured, what's being observed, is the amount that they're going to grow. I want to see how these plants are going to grow with the amount of sunlight that I give them. And so at the end of the day, tree 1 has grown 2 inches, and then tree 2 has grown no inches. It's because that's my dependent variable. It's what I measure. It's what I observed. At the end of our experiment, Billy and Susie. Billy gained, 2 pounds, and Susie gained 4 pounds. All right, I measure what's my dependent variable? Their weight. What I measure, how much they have gained. All right, so far we've talked about the independent variable. Independent variables are what I change in an experiment. Independent. Dependent variables depend on the change. They are what's being measured. Okay? And we have one more thing to talk about. The third variable that we're going to discuss in this podcast is a controlled variable, a variable that is not changed. They're also called constants, and they allow for fair tests. Let's look at this as back to my example with the trees. Tree 1 gets 5 hours of sunlight. Tree 2 gets 1 hour of sunlight. But let's say I decide to water tree 1. Tree 1 is getting water. Tree 2 is not getting any water. Is that fair? Could I say that tree 1 is growing solely on the difference in sunlight? No, I'm giving him water and I'm giving no water to tree 2. That's not fair at all. And you know what? Maybe Billy, he's an athlete, and Susie, she's a friend of the couch. She likes to hang out on the couch. She doesn't really do much. And so Billy, he gets the regular donut and he just works out all the time, so he doesn't gain as much weight. Susie, she gets the chocolate donut, and she sit there on that couch just flipping the TV. You have to take into those account. Plus, their metabolism could be very different. I didn't even talk about their age. Maybe Billy's a 16-year-old boy and Susie's a 49-year-old woman with cats. Who knows? All right? So, we have to be aware of the different types of controls. And what is the purpose of the control? What is the purpose of a fair test and a constant? The purpose of those things is to have something to compare to. If I just wanted to see if chocolate donuts made you gain weight, and I just give Susie chocolate donuts all the time and she gains 4 pounds, I said, oh, look, Susie gained 4 pounds. Chocolate donuts make you gain more weight. Compared to what? You have to have a control. And we'll talk more about controls a little later. But that's the basic idea. All right? So let's see how well we can do. We're going to look at a couple experiments, and I want you guys to write down on your own paper the independent variable, the dependent variable, and the control. You don't have to write out the whole word. I can pause right here and tell you what I want you to do. But let's look. All right, so here we go. Here's our first experiment. Students of different ages were given the same jigsaw puzzle to put together. They were timed to see how long it took to finish the puzzle. All right, this first one I'm helping you out with a little bit because I've highlighted some red parts. All right, students of different ages were given the same jigsaw puzzle to put together. They were timed to see how long it would take to finish the puzzle. So let's see. Identify the variables in this investigation. What was the independent variable? What did I or the scientist change in this experiment? Good. The ages of the students. Different ages were tested by the scientist. That's what we're measuring. That's what I'm changing. I am changing the ages. I'm letting, Billy, who's 4, and then Carl, who's 2, and then John, who's 19. I am changing the age. What about my dependent variable? What are we measuring here? We are measuring the time it took to put the puzzle together. Good. We can measure it. It's our observation. And can you tell me what is our controlled variable in this experiment? Good, it's the same puzzle. All of the participants were tested with the same puzzle. It would not have been fair to test somebody if they had an easy 30-piece puzzle as opposed to someone who had a 500-piece puzzle. That would be very, very hard. I hate puzzles, by the way. Here's another example. An investigation was done with an electromagnetic system made from a battery and wire wrapped around a nail. Different sizes of the nails were used. The number of paper clips the electromagnet could pick up was measured. So, once again, what are the variables in this investigation? What was my independent variable? What was I changing in this experiment? I was changing the sizes of the nails. All right, we had different size nails. I changed the size of nails that could be picked up. What was my dependent variable? My dependent variable was the number of paper clips picked up because we could measure that. It's what's being measured here. Okay, what was my control? The control is a little harder in this one, but it's not impossible. The control is of the battery wire and the type of nail. I kept all the nails the same. Even though I didn't explicitly say it, you assume. So I kept all the nails the same. Let's do another one. The higher the temperature of water, the faster an egg will boil. The higher the temperature of water, the faster an egg will boil. Okay? So, what is my independent variable? There it is. It's the temperature of the water. What am I changing in this experiment? I am changing the temperature of the water. What am I measuring? What's my dependent variable? My dependent variable is the time to cook an egg. That's what we're measuring. And what is my constant? We're probably keeping the type of egg the same. You know, I don't want to have a tiny little chicken egg and then have a huge ostrich egg. Like, oh, well, this one took longer. No. All right? Let's see. Last one. Promise. The temperature of water was measured at different depths of a pond. So as you going into the water, you're measuring the temperature of the water. All right, so the temperature of the water was measured at different depths of the pond. What was our independent variable? Our independent variable is the depth of water. I am changing where we go in the pond, how far we go down in the water. What are we measuring? What's my dependent variable? It's the temperature. That's what we're measuring. And then what's my independent variable? Or excuse me, my controlled variable? It's probably the thermometer. I'm keeping it using the same thermometer throughout the entire time. I'm not going to change thermometers halfway through and say, well, this one's more accurate and this one's off by a couple degrees. No, that wouldn't be a fair experiment. Okay? So the final thing I want you guys to be able to do is to design an investigation of your own. So as a class or in groups, we'll talk about it. Design an investigation to test this hypothesis. This is our educated testable explanation. The farther a ball drops, the higher it will bounce. All right. Identify the variables and what exactly will be changed, how will it be changed, and what exactly will be measured and how it will be measured. All right. So after this podcast, I hope that you have a good idea what an independent variable is. It's what I changed to an experiment. I hope you understand what a dependent variable is. A dependent variable is what is being observed or measured in an experiment. It's a result of the independent variable. And then a control is something that we keep the same. All right, it's a constant. It has to be the same for it to be considered a fair experiment. All right. I hope you guys have a good day.